In the previous video, we created an empty project structure. Now we'll start writing the code. And we'll start writing it from defining a contract for microservice. So the contract will have a definition of the data objects that are used to pass information between microservice and its clients. And it will have beacons version 1 object, beacon type enumeration, and validation schema. Under source folder, create data folder and logic folder. Then under data, create folder called version 1. The thing is that microservice over time is going to change. So we get to think about versioning since the beginning. And we will do it by doing two things. First of all, we will put all data objects under version 1 folder. So as we need to create a version 2, we'll just add version 2 folder under data. And then, as we define our data types, we'll add a vx suffix. So it will allow us to mix different data definitions from different versions in the same code without causing conflicts. Then under data version 1, we'll create a beacon v1 object. That's the object that will contain information about our beacons. It will inherit string identifiable interface from Pip.Services toolkit that requires a string ID. Site ID will define a site where a beacon is installed. Then there will be a beacon type, universal device identifier. That's the code that is emitted by beacon through Bluetooth protocol, human readable label, center of the beacon or location in GeoJSON format. And for simplicity, we'll just use any type here. And detection radius. Then we'll define a list of beacon types. Usually you would use enumeration, but different languages define enumerations in a different way. So to have portability, we will use just string constants. So here we'll have a known type, alt beacon, it's open source beacon definition, iBeacon from Apple, Eddystone UDI beacons from Google. And then we'll create validation schema for our beacons. We will inherit object schema from Pip.Services toolkit, and in the constructor we'll define fields for this object. Our site ID field and UDI fields will be required, and all other fields, including ID, will be optional. If we don't set ID, it will be automatically generated on the server side and passed back to the client as a result of create operation. So that will be our data contract for this microservice. Some teams decide to define data contracts to automatically generate using either gRPC protobuf definitions or OpenAPI definitions. I would suggest against using that practice, because if you generate your data this way, you will tie your implementation to a specific technology. For instance, if you generate your data definitions from protobuf, and then in the future you need to use a different communication technology, you will basically need to rewrite your entire code. So stay technology agnostic, and then you can use protobuf definitions later as you define external interface for a microservice, and you'll convert objects from external representation into internal. And then we will define contract for business logic. Under logic folder, we'll create iBeacons controller interface that will have a few operations. In all operations, we'll be using correlation ID as the first parameter. That's one of the patterns that we use consistently through our entire code base. Correlation ID will allow us to trace a sequence of operations between the microservices. Then getBeacons will receive filter parameters and paging parameters and return a requested data page. GetBeacons by ID will receive unique beacon ID and return beacon, and getBeacon by UDI will receive universal device identifier and also return the beacon. Calculate position operation will receive site ID and list of detected UDIs around the user, and then by that information it will triangulate position of the device. Then we'll have create, update and delete operations. Now let's open the terminal, run npm install command to install packages, and compile the code using TypeScript compiler. Compiler shows no error. We can see object folder in our microservice folder, so that means that compilation was successful. In the next video, we are going to build persistent components for microservice. that will store beacons information into the database like MongoDB or other types of persistent storages, and then it will allow to retrieve us using different filter parameters.